The objective of U.S. Army research and development is to develop new weapons and equipment to support the individual American soldier. As never before in history, the future of your Army depends today on its research and development program. The battle of brains and pencils and blueprints, of imagination and innovation, is being waged in laboratories and industrial plants across the nation. The Army's research and development program covers many areas. There must be greater mobility on the ground and in the air. The need for increased firepower is being met with weapons that are smaller, lighter, and more potent. For command and control, better communications are required. The modern Army needs and must have improved logistical support that is more responsive and flexible to match fluid battlefields. With each technological advance, the importance of the individual soldier increases. Thus, the Army Research and Development Program is concerned primarily with this soldier. Research and development is constantly striving to give the American soldier every advantage in any future combat. Not only must this soldier be better trained, but he must be able to exist in the severe environment of nuclear or chemical attack. To show some accomplishments thus far, as well as new concepts being tested, here is a special progress report from the files of the Office of the Chief of Research and Development, Department of the Army. The Courier, designed as the forerunner of a series of outer space communication satellites, was developed under the technical direction of the Army Signal Corps. Its electronic equipment is designed to use frequencies in the ultra-high range never before used for satellite communication. This frequency band has the advantage of being free from man-made signals and natural disturbances such as magnetic storms, which can blanket the lower frequencies. Power for the satellite equipment is furnished by miniature batteries charged by thousands of solar cells, which convert solar energy into electricity when the satellite is in sunlight. The Army Courier was launched in October 1960 at Cape Canaveral, Florida. During its operational period, the Courier satellite relayed millions of words by teletypewriter, voice signals, and for the first time actively relayed photo facsimile through outer space. Commands to and communications from the satellite were coded to avoid unauthorized use of its capabilities during this experimental phase. Courier is known principally as a delayed repeater, meaning it stores information until commanded to transmit, rather than relaying it directly. In addition, during some 89 orbits, when the satellite was in view of 2 ground stations, messages were transmitted instantaneously from one station to the other, proving the feasibility of this direct relay mode of communications. This 28-foot antenna automatically locks on and tracks the satellite when it comes within range. When in full operation, Courier is capable of receiving and sending approximately 72,000 words a minute. The information received is stored on tape recorders in the satellite and later transmitted to the next station. In the Courier test, communications were established with 2 ground stations, one in Puerto Rico and the other at Fort Monmouth. Several couriers could greatly relieve the currently crowded radio spectrum and avoid the inherent limitations of transoceanic cables. Moreover, Courier would not interfere with present television and radio transmissions, which are on much lower frequencies. The results of this program, coupled with those of the Army's more advanced communication satellite, Advent, may ultimately revolutionize worldwide communications. Sergeant is a solid fuel guided missile. The Sergeant system was designed and developed to meet a wide variety of environmental conditions. It will replace the Corporal. The launching station, completely integrated, is mounted on a single vehicle. With such mobility, the Sergeant may take up its firing position in any practical location. The launching station is powered by a self-contained turbine generator set. Hydraulic lifting and leveling is controlled by a single man from one point. Emplacement of the launching station can be accomplished in a matter of minutes. The launching station even carries its own crane for lifting the missile sections out of their containers. The Sergeant is an all-weather missile, in transit and storage as well as in operation. These components, now arriving at the launching site, were checked out for functional dependability in another part of the battalion area. Sequential assembly begins with the rocket motor section, with its solid propellant. This is the heaviest section. Next is the guidance section, containing the electric power units, the inertial guidance system components, and the hydraulic drag brake system. The four-body section contains either a nuclear or a non-nuclear warhead and associated arming and fusing devices. Length of the missile is 34½ feet. The diameter, 31 inches. The four interchangeable control surface assemblies lock in place without tools. Electric connections are made automatically as soon as the assemblies are locked in place. When the missile has been assembled on the launching station, all personnel except the firing set operators evacuate the immediate area. The Sergeant is fired from a remote control position. It operates in all weather conditions, delivers a powerful tactical punch, arrives on target at better than the speed of sound, and has a range far exceeding conventional artillery. The Army is researching the military use of air flotation vehicles, machines without conventional wheels, axles, transmissions, clutches, or the usual brakes. Ground effect machines, such as this flying scooter, operate close to the ground, supported by a cushion of air. In the scooter, the left handlebar has a throttle control for a small 7-horsepower Nelson engine. Air is drawn in by a fan system and directed down and out around the base of the scooter. This lifts the vehicle approximately 3 inches off the ground. The highly maneuverable flying scooter weighs only 300 pounds. The user controls movements by shifting his weight in the direction of travel. The flying scooter is one of 2 machines constructed by the Forrestal Research Center of Princeton University for Army Research and Development. The same principles are used in the flying donut, but with more refinements. The single-seat cockpit has a conventional aircraft stick. Lift and propulsion are provided through a ducted propeller. A foot-operated rudder control turns the donut by swiveling a smaller propeller mounted on the rear. The main propeller is driven by a 55-horsepower engine, which produces a lift of approximately 6 inches. When the rudder control is activated, the tail propeller turns the machine in either direction while running or hovering. The Flying Donut has moved at speeds up to 25 miles per hour. The ground effect program also includes 2 off-the-shelf Curtiss-Wright air cars. This one seats 4 or has a payload capacity of 1,000 pounds. Simple controls permit the operator to maneuver the vehicle in any direction by controlling airflow through adjustable vanes. 2 180 horsepower aircraft engines power the ducted propellers for speeds up to 35 miles per hour with an operating range of 2 hours. Air performs the important functions of propulsion, suspension, and braking. The machine is capable of turning on its own axis. The normal lift for the air car is approximately 6 to 9 inches above the ground. Since ground effect machines move on a cushion of air, they can travel over any unobstructed terrain, water, mud, swamp, ice, or snow. With this research program, the Army truly takes a step into a new field which may offer improved surface mobility. One of the Army's latest solid fuel missiles, the Pershing, underwent a successful test firing less than 2 years after contracts were awarded. Subsequent firings continued to reaffirm the increased reliability of this advanced missile system. Assembly of the first Pershing in the R&D test firing program was completed in November 1959. Individual components had been subjected to rigorous testing before being installed. Following assembly, the missile was given thorough quality assurance tests. The development test firing also featured testing of prototype items of ground support equipment, such as this Transporter Erector Launcher, or TEL for short, which has proved very effective at its job of elevating and launching the Pershing missile. The ground transport vehicle for the Pershing, the XM-474, gives the missile system the kind of field mobility required in modern combat. The XM-474 is the prime mover for all major units in the Pershing ground mode of tactical mobility. In tactical employment, as demonstrated here, the missile will be carried and erected by the TEL mounted on the tracked vehicle. It takes only 1 minute to erect the missile. The Pershing is a 2-stage solid fuel replacement for the liquid fuel Redstone. Moreover, the Pershing is smaller and lighter than the Redstone and will ultimately have greater range. The TEL can quickly return the missile to the carrying position should a change in the tactical situation require a shift in firing sights. In February 1960 at Canaveral, Pershing's first launching proceeded smoothly. The control system performed satisfactorily throughout powered flight. The propulsion system operated normally through burnout, which occurred as scheduled. Missile velocity at burnout was close to that predicted. In the initial and subsequent firings, the Pershing ballistic missile and its ground support equipment successfully accomplished all their primary functions. Helicopters may be employed to great tactical advantage when flown at low speeds and close to the ground where their vulnerability is reduced. The Army-Navy instrumentation program, called ANIP, is an effort to retain this flight capability in zero visibility conditions and still avoid obstructions, be able to navigate, and take off and land safely. A basic aim of ANIP is to simplify piloting by reducing the number of aircraft instruments and the training required to interpret them. ANIP has developed a display in which a grid representing the Earth's surface indicates the plane's attitude and orientation. This graphic representation is far easier to interpret than existing instruments. When the psychological and operational advantages of this concept were proved, computers were designed to produce flight effects in a helicopter simulator. The only one of its kind, it produces all the sensations of real flight, but permits more accurate and economical study of the performance and reactions of a large number of pilots. The computer generates a display with a grid to represent the Earth. Terrain features that may be potential dangers are stylized. This is the forerunner of more advanced displays, which will use high-resolution radar to reveal other air traffic and terrain obstructions and provide a map display as well. A flyable research model was also built and installed in a helicopter. Its purpose was to accumulate preliminary data on the ANIP display concept in actual flight. As the helicopter maneuvers, its true aspect in relation to the ground is portrayed by a grid projected on a screen. But the screen is transparent. When visibility is good, the pilot can see the ground through the display. If visibility is lost, the grid still shows the aspect of the craft in relation to the ground. The feasibility of the ANIP concept has been proved. Its use can increase the effectiveness of air support, not only for helicopters but also the Army's fixed-wing aircraft. The natural, easy-to-understand display methods will reduce pilot training problems. Additional research for more refined systems will be continued through the coordination of Army-Navy effort and the contributions of several hundred American industrial firms. Tests of the improved Nike Hercules system are currently underway at White Sands Missile Range to prove its technical capability of intercepting ballistic missiles. The test you are about to witness is the intercept of our early type Corporal missile by a Nike Hercules. The Corporal, which is a Field Army type ballistic missile, stands 45 feet high, is 30 inches in diameter, and has a range of 75 nautical miles. The nuclear-capable Nike Hercules used for this test will carry a high-explosive warhead. New radars have been added to the basic Nike Hercules ground guidance equipment to permit the system to acquire and track high-performance targets. Target ready. Target countdown.
6, 5, 4, 3, 2, 1.
Fire. Target on the way. An Army civilian team at the Nike Hercules site, 50 miles away, will acquire the target, only 30 inches in diameter and more than 10 miles up. Target acquired. Target tracked. Fire. On the basis of tests already conducted, the improved Nike Hercules system shows a technical capability of intercepting and destroying enemy ballistic missiles long before they can land on their intended targets. The modern individual mask is highly efficient in protecting the respiratory tract from biological and chemical agents that can be used in warfare. But V-type nerve gas and mustard gas produce casualties by contact with the skin. Masks are not sufficient. Specially treated combat clothing has been developed to protect against these chemical agents. But even with their use, further precautions may be necessary to prevent casualties. For this purpose, a decontamination and treatment kit is being developed. It consists of a bag of dusting powder and a dye indicator. Crushing the dusting bag breaks a capsule containing the dye. Kneading mixes the powder and dye. When dusted on exposed clothing or weapons, the powder neutralizes any small drops of the nerve gases or vesicants that may be present. If larger drops are present, they are revealed by a color change of the dye indicator. These spots must be treated another way. The kit includes metal patches. They are applied to prevent nerve gas or mustard from penetrating to the skin. Also, cloths are provided for washing and swabbing skin areas with a different decontaminating agent moistened with water. Decontaminant is also applied to weapons and personal equipment to prevent contamination from handling. The kit can be used for decontaminating mustard as well as the nerve gases. The M17 protective field mask has been improved to provide better vision and easier breathing. With no external canister, it's less cumbersome to the wearer. A similar design, including hood, is used for armor personnel, but it has an added feature for comfort and efficiency. The canister in the mask connects to a large central canister in the tank. A quick release permits dismounting without loss of mask protection. These new developments will make it possible to live and fight in a toxic environment. The M88 is a recently developed full-track recovery vehicle capable of sustained speeds up to 30 miles per hour. It can perform rescue and recovery operations of disabled tanks weighing up to 56 tons. The M88 was designed to include the best features of previous model recovery vehicles, as well as many new features. There is a crew compartment armored against small arms fire, medium artillery shell fragments, and anti-tank mines. The equipment includes a spade dozer, 2 winches, power takeoff, and a modified A-frame boom. The boom is powered and controlled hydraulically and can safely hold a 25-ton load. The main winch has a capacity of 45 tons with a single line. The M88 is designed to operate primarily with the M48 tank series and the new M60 tank, but it can also, if needed, support armor units with other types of vehicles. To simplify ordnance maintenance and repair, this recovery vehicle uses many parts in common with current tank series. This aluminum-hulled amphibious cargo carrier, recently standardized, is a versatile lightweight vehicle employing the M116 chassis. In snow conditions equal to the worst found at Arctic test stations, the 7,200-pound carrier has excellent mobility. Its snow performance is due to a low ground pressure and the aggressive action of the tracks. In addition to accommodating 11 men with equipment, the carrier will tow 12 skiers. It has a water-cooled V8 engine and 4-speed hydromatic transmission. Clutch brake steering is used for soft terrain, geared steering for normal road travel. With a capacity cargo of 1.5 tons, top road speed is more than 40 miles per hour. Cruising range about 300 miles. The new carrier enters water without special preparation. Although the aluminum hull is watertight, 2 bilge pumps are provided to handle casual water entry. At the rated payload of 3,000 pounds, it has 14 inches freeboard. The vehicle tracks work efficiently as propellers. Water speed is approximately 4 miles per hour. Transportable in a C-124 aircraft, the agile full-tracked carrier is a replacement for the World War II Weasel. In May 1960, the new long-endurance unmanned aerial surveillance system, the SD-5, was sent to the drone test facility near Yuma, Arizona for its first powered flight. The SD-5 is part of an all-weather system being developed to give the Field Army greater capabilities in aerial surveillance and tactical mapping. The drone is constructed primarily of molded fiberglass, which makes the airframe lightweight, yet strong and highly resistant to impact damage. The drone's length is 36 feet 8 inches, wingspan 24 feet 8 inches. Obeying its electronic controls, the drone will normally fly to and from its mission area at treetop level. Immediately after the launching, the booster falls away and a jet engine then powers the drone's flight. The SD-5 will rise to higher altitudes in accordance with its preset programmed course. It is also equipped with terrain avoidance radar, which ensures it against impact damage during low-altitude flight. In this initial test program, however, the drone contained only interim electronics. Range instrumentation was used for tracking and control. Later test flights will gradually include operational electronics for navigation, control, and other functions. For distances beyond radar lines of sight, the SD-5 follows a programmed course and can switch to a preset alternate course if necessary. It will be equipped to carry interchangeable packages of radar, infrared, and photographic sensors. Surveillance data from these devices can be permanently recorded in the drone and can also be transmitted back to friendly lines during flight. Upon completion of a mission, recovery parachutes are automatically released according to a programmed flight plan or ground station command. Then large rubberized pneumatic cushions are released and inflated to soften the landing impact. Thus the drone and its valuable sensors remain intact and can immediately be prepared for another mission. This new unmanned aerial surveillance system will offer the Field Army commander significant new capabilities in combat surveillance and in providing target information for the Army's long-range missile systems. Your Army's research and development program is a continuing effort to help ensure the survival of this nation. Army industry teamwork is vital to the accomplishment of the Army research and development mission. To maintain superiority in our military arsenal, new ideas are essential. New weapons must be developed and perfected to meet new requirements. In these days of explosive advances in science and technology, Army research and development plays a major role in maintaining America's military supremacy.